All right, 8th grade, we are going to look at 3-8 unions and intersections of sets today. If you would please go ahead and pause your video, get out some loose leaf, do your heading, your vocab, and then come back to the video. All right, so our vocab, we have 3 vocab words: union, intersection, and disjoint sets. Union is represented with a U. It does not have a tail on it, just a U. And it is when you combine 2 sets. So this, no tail, let's see. This would be the union of A and B. It's everything that's included in both A and B. An intersection is the overlap between the two. That is an upside down U. When you're talking about an intersection, that's the area in between that is in both A and B. Disjoint sets are completely separate. So if we had A here and B here and they did not overlap at all, those are disjoint sets. One, they give us this example where we have some things in our left pocket and our right pocket. In our left pocket, we have a quarter, a paperclip, and a key. In our right pocket, we have a penny, a quarter, a pencil, and a marble. The first thing that they ask you to do is list out what is in both sets. So we are using a roster form where we're just listing out what's in our sets. So we say L, and notice it's capital L because sets are capital letters. So L equals, and then in brackets, we list out the items in there. R, so it's supposed to be an equals. And then again, we list out in brackets what is in our right pocket. If we then say, well, what is the union? These in my head. If we ask what is the union of set L and R, union means everything that's in both. So when you list out the union, again, we are going to put that in brackets. You'll notice that quarter is on both of our lists. We only need to write that one time though, and say quarter. Let's see, paperclip, key, penny, pencil, and marble. Don't actually write and, I would just talking. So we have our quarter, paperclip, key, penny, pencil, and marble. That is the union. If you were talking about the intersection here, so that's when we use the upside down U. So I'm saying the intersection of L and R, that would be quarter because that's the only thing that is in both. So that would be our intersection, would be quarter because that is what is in both L and R. We don't have disjoint sets because they do overlap on quarter. They both involve quarter. So that is example 1 or problem 1. If you want to go ahead, pause your video and do got it 1A, then come back and I will go over that. For got it 1, they tell us in set builder notation that P equals all real numbers X such that X is a whole number less than 5. We are supposed to write that in roster form. So this would be your roster form for P. Whole numbers start at 0, go 1, 2, 3, 4, and it said less than 5, so we don't include 5. Q is all real numbers Y such that Y is an even natural number less than 5. So natural numbers start at 1, they're the counting numbers. So that first even would be 2, and then we would also include 4. For P union Q, that's going to be anything that is in both P and Q. So essentially, it's everything that's in P, because 2 and 4 that are in Q are also in P. So this would be P union Q. Just as a bonus, if we were talking about intersection, let's say the intersection of P and Q would be 2 and 4, because those elements are in both P and Q. So moving on to problem 2, that does talk about intersections. They give us 2 new sets here. They give us x, which is all real numbers x, such that x is a natural number less than 19. Well, they give us 3 sets. Y is all real numbers y, such that y is an odd integer. And z is all real number z, such that z is a multiple of 6. So they want to know what is the intersection of x and z. So as a reminder, x, all real numbers less than 19, all natural numbers less than 19, and z is multiples of 6. So for the intersection then, we would start with 6, go 12, and 18. That will be the intersection. That's as high as we can go because x only went up to 19. So that's it for our intersection there. The next one, they ask what is the intersection between y and z. So y again was odd integers, and z is multiples of 6. So odd integers, odd integers and multiples of 6. So I think that's actually an empty set, because if we think about our multiples of 6, starting with 6, 12, 18, 24, they're all even. There are no odd multiples of 6. So this is actually just the empty set, because there's nothing that overlaps between y and z. Go ahead, pause your video, try got it 2, and then come back. For got it 2, they give us 3 new sets. A has the members 2, 4, 6, and 8. B has members 0, 2, 5, 7, and 8. And C is all real numbers n such that n is an odd whole number. So we are going to start out, these are intersections, so these are where our Venn diagrams would overlap each other, or what's in both sets. So the intersection of A and B, where A and B cross, you can see would be 2 and 8. So our set here would be 2, 8. The intersection of A and C, so we have A here, and then C is an odd whole number. So you're going to check, we have no odd numbers in A, so this would just be an empty set. C is the intersection of C and B, so let's see. We do have some odd whole numbers in set B, so the intersection of C and B would be those odd numbers, 5 and 7. So there you have it. That is got it 2. And we are going to go ahead and look at problem 3. If you look either in your book or at the pages I sent you, problem 3 is about 3 different book bags, and they have shown us what is in each book bag. So in the Venn diagram, they have the yellow bag, the red bag, and the blue bag. And it is saying, which items do all three friends have in common? So all three of the book bags have water, hat, and a map. That would be the intersection of those three sets. The yellow bag, the red bag, and the blue bag all have water, hat, and map. When you look at Got It 3, it it shows us some new sets. Set A is the first 5 letters of the English alphabet, so A, B, C, D, E. B are vowels, and C are the letters in the word vegetable. So we are supposed to figure out what is the intersection of all of those sets. If you want to go ahead, pause your video, figure that out, and then come back. Alright, so in Got It 3, our first set A, is A, B, C, D, E. Set B is the vowels. And C is the word vegetable, randomly. So we're supposed to figure out where these 3 sets intersect. And, oh dear. So we have an A here, a vowel, and in set A. So A would be in our set. B is not a vowel. C is not a vowel. D is not a vowel. E is here, here, and here. So our overlap or intersection between those 3 sets is just A and E. So that's Got It 3. Problem 4 has another Venn diagram. Well, these ones are fun. These are like logic puzzles, so I enjoy them. You need to set up your Venn diagrams correctly if you're going to get these. So let me just erase this, and then we can break down this problem. So problem 4, it says of 500 commuters polled, some drive to work, some take public transportation, and some do both. 200 commuters drive to work, and 125 use both types of transportation. How many commuters take public transportation? So they tell us we have 500 people that have been polled. So that's going to include everyone that has been polled. And we're going to write our 500 up there so that we remember that's how many people should be our total. The next thing that it tells us is that some people drive to work, some take public transportation, and some do both. So we're going to have 2 circles. This will be, we'll call it D for drive and P for public. And it says that 200 commuters drive to work. So we know that 200 people drive. We don't want to put that in the circle yet though, because it tells us how many people overlap, which is 125 people. So we're going to put the 125 people in the middle here. We can then figure out how many people drive but don't use public transportation. So you would take the 200 minus the 125 that do both. And you can say that 75 people drive only. So we have how many people drive only, how many people do both. Now we can figure out how many people only take public transportation. To do that, we are going to take our total 500 and subtract 200, the number of total people that drive, and that gives us 300 people only use public transportation. Now remember that they are not asking us how many only use public transportation. They're asking us how many commuters, not computers, how many commuters take public transportation. So that would be the people that only take public transportation and the people that take public transportation and sometimes drive. So we're going to add the two of those together, and that gives us how many people take public transportation in total, which would be 425. Go ahead, pause your video, try got it 4, and then come back. So got it 4 it tells us that there are 30 students in student government. It tells us that 20 of those students are honor students and that 9 are both honors and officers. So we know this much information so far. We can deduce from that that there are 11 students who are honor students but not officers. We can also deduce from this that if there are 11 students over here, that means that there are 19 that are officers. 9 of those 19 we know are both honor students and officers. So that leaves 10 left that are officers but not honor students. So Venn diagrams are really going to be your friends with these. You need to make sure that you are reading very, very carefully what belongs in each section, whether it is out here, it's alone, or if it's a intersection that is going to be in both circles, or is it the total number between what's by itself and what's in the intersection. So you need to really be careful about which section you're putting those numbers in. But when you get them in the right section, you can usually then figure out what is left in the section that you are trying to figure out. So what I want you guys to do next is try some of these problems. I'm going to have you do pages 234 to 235, and I want you to do 11 to 27 odd. You will submit that work on Rediker, and then I will post a video where I go over the answers, and I want you to watch and make corrections and take any notes of any questions that you want to ask, either in our next Zoom or in your class's discussion board on Rediker. That's it for now. See you guys soon.